My name is Jagannath. I am a fourth year undergrad student at IIT Kharagpur and welcome to my channel The Coding Project. In this video, I am going to discuss the solutions of all 19 introductory problems of CSES problem set. So, on all other YouTube videos, if for every single question they are taking around 20 to 30 minutes of time. I am going to discuss all the 19 questions of the introductory problems in within the less amount of time which is available in the YouTube. So this video is going to be very special. Without wasting any of your time and my time, I am going to deeply dive into all of these solutions. So here comes, this is the last question. Let me come to the first question. Yeah, so this is the first question. What is this question is, consider an algorithm that takes as an input a positive integer n. If n is even, the algorithm divides it by 2. Say if n is equals to 4, then it will be dividing it by 2. If it is 2, it dividing by 1. And if n is odd, the algorithm multiplies it by 3 times and by 3 and adds 1. For say it is 3, then 3 will be multiplied by 3. 3 is 9 plus 1 will becomes 10. 10 is an even number, so 10 by half is equals to 5. 5 is an odd number, so 5 into 3 times 15 plus 1 becomes 16, and 16 is an even number, it comes to 8. 8 is an even number, it comes to 4. 4 is an even, it comes to 2. 2 is an even, it comes to 1. In this way, the algorithm repeats this one if n is 1 until n is equals to 1. So we have, for example, n is equals to 3. This is the following sequence. So our task is to simulate the execution of the algorithm for the given value of n. This is very simple question, as it's straightforward. We need to check whether if given n is divisible by 2 or it is divisible or it is not divisible by 2. If it is divisible by 2, then we just need to make half and we just note the value of n. At that moment, if it is equals to half, then we just need to multiply it by 3 plus 1 and note that value or store the value in a vector also. At the ending, we can print all the values of the n which was iterated. So for the solution, we don't need to do any explanation. Directly we can go to the code. So this is the code for solution. So in this question, so here initially the main this iOS based sync with studio, this is for increasing the time and use including bits std c++. These are library which contains almost all the possible libraries which are important for the computer programming. And this is the main code starts from here. Int n, if cn equals to n, and vector int of ans, this is a vector, this answer is a vector. We can store the values of the n which are being iterated. Initially we'll be pushing the initial value of n into ans, so ans dot pushback of n, and then later while if n is not equals to 1, if n is not equals to 1, then if it then we should iterate till n is equals to 1. So we can break if n is equals to 1. So in that way we should make a condition that n is not equals to 1 while n is not equals to 1. So first, if n percentage of 2 is equals to 0, means n is divisible by 2 or n is an even number, then we are dividing n by half. Else n is equals to n into 3 plus 1. We will be multiplying by 3 and adding a 1. And after doing the operation, we will be pushing the value of n to the answer. At the end, we are printing all the values in the answer vector. Cout x space. At the ending, cout endl. So this is the simple code for this problem. This code works and it got accepted. You can see here. It's accepted. So let's go into the next question, missing number. Yeah. So in this question, you are given all numbers between 1, 2 up to so on n, except 1, means we'll be having, so for example 5 is the input. If you check it, the input, you'll be having 5, 2, 3, 1, 5. 4 is missing, right? So for the 5, for n belongs to 2 to 10 to the power of 2 to the power of 10 to the power of 5, we'll be having all numbers 1, 2 up to so on n, except one of the numbers in between. Now we need to find what is the number which is missing, and we should return or we should print that number. So this basically we can easily identify it as we should implement a hash map. So by the hash map we can check the following: if every element is present in the hash map, whatever element which is not present in the hash map, we can return that as answer. And we can make as soon as we got input from here 2315, we can mark true in the hash map, and we can mark all the false initially. So after marking each and every element, after taking the input, whatever number which is left as false in the hash map is the answer, and we should print that answer. So that's it. So in the code we can see the starting thing will be the same template for almost all the questions: include bits std, c++, int main, and int ios base sync stdio. These all are same. So int n, we should take what is the value of n. After taking the value of n, vector bool check n plus 1 comma false. We'll be checking what is the value. We will be implementing a check hash map with n plus 1, because the range is from 1 2 3 up to so on, and we should include n. If it is taken only till n, then we will be having access to only n minus 1. We will be initializing to false. It doesn't need to specifically mention false here. By default in the C++, it will be initializing to false only, but we can implement for right here false also. Check of 0 is equals to true. For int I is equals to 0, I is less than n minus 1, and I plus plus. These are, it's checking like these are the n values. It's not n, it's have actually we'll be taking only n minus 1 value. That's why it is implemented till I is equals to 0 to I is less than n minus 1. It only takes n minus 1 values. So int x, scene x, we'll be reading the input number and marking it as true in the hash map. And for int I is equals to 1, I is less than or equals to n, I plus plus. For I is equals to 1 to n, we will be checking if it is false. If any of the hash map value index is false, then we will be printing that index as the answer. And we'll be breaking, because once we got an answer, once we have printed, we don't need to check for any other hash map. This saves the time basically. So in this way we'll be just implementing a hash map, and by implementation of hash map, if whether after taking the input, if it is present in the hash map, then we can skip. If it is not present in the hash map, if it is false, then we need to print that answer. So that is the simple code for this question. In the third question, this is third question. So in this question, what they are asking is, as the name suggests, repetitions. There is given a DNA sequence, or we are given a string. String contains only values A, C, G, T. The DNA is a sequence which consisting of only A, C, G, T. Adenine, guanine, cytosine, thymine. A, C, G, T. So your task is to find the longest repetition in the sequence. We will be given a string sequence. We need to find the longest repetition of a single character in the sequence, and we need to return the max length of the substring containing only one type of the character. So basically we can use implementation of a 2-pointer type of thing here. We can implement two variables, left and right. If left and right is equals, if left is equals to 0 and right is equals to 0, index initially. If we got both the left index and right index values equal, then we can go to the next index. We can increment the right till we got the same values at that particular index of the right and the left. If we got encountered a particular index such that the value array element of that index is not equals to the value at the left index, then we should increment the left to that particular index. So let me show you in like this. Yeah, so basically we will be having an array. Basically we will be having an array. This will be initializing to left and right over here itself, left and right here itself. If we'll be checking if air of left equals to air of right. If it is equal, then we will be incrementing right plus plus. right plus plus, and if else we will be making left or L, which is, this is a pseudo code, it's not exactly code, we will be discussing the code also. Left is equals to right, and in the between, while we are incrementing the right, we will be maintaining the max and answer. Ans is equals to max of ans comma, like the difference between the right and left, such kind of thing we can store, such that we can get the maximum distance of particular thing. So for the given example, if we check, the given example is A TT C triple G A TT C triple G A. So initially R equals to 0, L equals to 0, both are 0. So we will be checking, yeah, if it both are equal. Now we will be incrementing R towards, let us make a notation, let us make R it down and left it up. So both are equal, so R increments and it's go towards T. Now the both are different, so we will be incrementing L towards here, and now L becomes here, R will be here. Now we will be checking, now we will be initializing this towards L and R. We will be checking if L is equals to R. Yes, it is equal. Now we will be initializing incrementing the R. Now R will be going to here. Now both again are same, T and T. Now we will be again incrementing the R here, C. Now both are not same, so we should again increment the L to this particular position, and now both are equal, so the R will be initialized to the next thing. Again they are not equal. Now we will be incrementing left towards here. Now the left and right are equal, we will be going to the next thing, right, or both are equal. Now we will go to the next thing. Now both are equal, we will be going to the next thing, both are not equal. Again we will be coming to here. So when, if we reach it the last ending position, when left is equals to the last thing, then we will be stopping the iteration. In the between, as soon as we are incrementing R at every time, we will be maintaining the value with the difference between L and R. Here it is 1, here it is 2, and here it is again 1, here it is 3, here it is again 1. So 1 2 1 3 1. So the 3 is the max value, and this max value will be stored in max variable, and we will be printing this one. So in this way we will be going from the first index to the last index by using the two pointers left and right, and we will be maintaining the maximum count till now, the difference between the left and the right pointer, and we will be iterating till the end of the array. So this is the logic behind this problem, simple logic. So if we look into the solution for this thing in the C++ code, the same which I have discussed is implemented over here. Yeah, so here initially we will be taking a string CSES. We will be reading the string. We will be initializing few pointers. Left is equals to 0, right is equals to 0, answer is equals to 0, and cur is equals to 0. Cur is the current length between the left and right, that is the current one. Instead of every time we will be updating the left minus R, I have used another variable so that it will be easy. So while left is not equals to s dot size, while left is not reached at the end of the string, we're still continuing the thing. If s of right is equals to s of left, if the element at the right index is equals to the element at the left index, then we will be incrementing the right, and we will be incrementing the cur length. Cur means current length, and answer also will be maintaining the maximum of answer of and current length. If it is not equal, then we will be maintaining left is equals to right. We will be updating the left, and we will be initializing cur is equals to 0. Here cur is equals to 0 because initialized with the initially left and right are equals to 0. We will be checking for each and everything again and again. If it is equals to 1, then if we again check cur right is equals to left, it will be updating twice, and we will be having an error count. So this is the cur is equals to 0 is the correct thing over here. So that's it. At the ending we will be returning or we will be printing the answer. It's just small compile report, this accepted code. That's it. The simple 2-pointer method, left and right, and we'll be iterating till the ending of the array, and we'll be returning the max value which we encountered in between the traversal of the array. So that is the solution for this third question. Moving towards fourth question, increasing array. So in this question you are given an array of n integers. You want to modify the array so that it is increasing, that is every element is at least as large as the previous element. Means the, for example, as an input given the 5 3 2 5 1 7. I'll show 3 2 5 1 7, right? So input is 5 3 2 5 1 7. 3 2 5 1 7, yeah. So here what we need to make, so 3 is there, now we go to 2 is decreasing, this should be increasing, so 2 can be 3 or large, so 2 can be greater than or equals to 3. This value should be greater than or equals to 3. What we need is that we need minimum number of moves. So what we need, we can increment any value any number of times, but we need minimum number of moves, and the given condition is not strictly increasing. This 2 value should be maybe equal to 3 or it can be greater than 3. So what we will be doing is we will be incrementing 2 with 1 plus, and it will be becoming 3. So here the step is equals to plus 1. If now the new array will becomes 3 3 5 1 7. Now this till here it is increasing. Again we encounter 1 which is less than 5. So as a response we will be increasing with plus 4 and making it 5. Now 3 3 5 5 7. This is absolutely increasing function. So this is what he is asking to do us, and he is asking us what is the minimum steps such that the given array will be in an increasing order. So whatever we have done here in this example is what we are going to implement in this code also. We will be just checking from the first index, from this is 0 1 2 3 4, from the first index, if it is equals to the previous one. If it is less than previous one, then the number of steps required is the difference between the previous and the current one. If it is greater than or equals to the previous one, we don't need to do anything and we just need to move to the next thing. So this is what we will be doing or we will be implementing in this question. So coming to the solution. So the first template is same for all the things. So we will be starting with int n. C in n, the n is the number of elements in the array or the size of an array or a vector, whatever we can say. Array.resize of n. After taking the input from here, this line, answer will be initializing answer as 0, because the worst case we don't need to do anything and we just need to return 0. So answer is initialized to 0. And for int I is equals to 1, we don't need to check for the first element itself because there is nothing before it, so that we can judge it on the before element. So we will be starting with the first index, or the index is equals to 1, or the second element in the array. So I is equals to 1 till n minus 1 till the last element. If error of I is greater than or equals to error of I minus 1, we don't need to do anything and we just need to continue. Here continue. If it is not true, if continue is not arrived of here, we will be directly incrementing the answer as the difference of error of I plus minus 1 minus of error of I. Here error of I minus 1 is greater, that's why it is in this direction, error of I minus 1 minus error of I, and we will be changing error of I to error of I minus 1 because we need the minimum number of steps. So in this way, and we will be returning the answer at the ending of the loop. So in this way we will be implementing this question. This is also a simple question and simple solution. Now we will be moving to the next question, permutation. So in this question, A permutation of an integer 1, 2 up to so on n is called beautiful if there are no adjacent elements whose difference is 1. Means what he is saying is that the 1, 2 so on n elements will be there. Now no two adjacent elements should be having a difference which is equals to 1. For suppose here in the given example 4, 2, 5, 3, 1. The difference between 4 and 2 is 2. 2 and 5 is 3. 3 and 5 is 2. And 3 and 1 is 2. So the difference between any of the elements, consecutive elements, is not equals to 1 or less than 1. So he is asking that. So he is asking us to find a kind of permutation if possible. We need to print that kind of permutation, and using the numbers 1 till n, he will be giving only n, and we need to return the permutation if possible with all the numbers using 1 till the given number n. So if there are no solutions, then we just need to print no solution. So this is a very is also looking a little trickier, but it's very simple question indeed. So but the base cases for the 2 and 3, n is equal to 2 and 3, it is impossible to make a permutation whose values, whose difference is less than, greater than, equals, greater than 1. So 1, 2. 1, 2 is there, or 2, 1. These two are possible. So basically it is not possible for the value 2 to make a permutation whose difference is greater than 1, because there are only 2 elements and there are only 2 possible elements, so it is not possible. For 3 also, 1, 2, 3. What are the possibilities? 1, 2, 3. 1, 3, 2. And 3, 2, 1. 3, 1, 2, and so on. So in whatever case we check, at least one pair will be having difference equals to 1, and we can't get rid of the thing. So this is also a trivial case. So 2 and 3 values of n, if as soon as we got n is equals to 2 and n equals to 3, we just need to return not possible. And for n is equals to 1, we just need to return 1. That is the single case. It's also like a trivial case. We just need to return 1. So that is so here. And so what we are going to implement over here is, for any value greater than 3, say 4, 5, 6, 7, 8, and so on, the simple logic for implementing this is, first print all the even numbers. Say n is equals to 6. N is equals to 6 means first print all the even numbers. 2, 4, 6. Now print all the odd numbers. 1, 3, 5. Over. So this is the permutation required. That simple is it. So in the similar way, for any value which is greater than 3, we just need to print all the odd numbers or all the even numbers first, and later we can print all the even numbers or all the odd numbers. So that is the simple solution for this problem. So in the C++ code, we will be implementing in the following way. Here there is a small trick over here, small loop over here. After taking n, if n is equals to 1, we will be returning out 1. If n is equals to 2 or n is equals to 3, see out no solution, and there is no solution indeed. So if now what we'll be doing is that if n is equals to 4 or n is equals to 5, it doesn't matter for the number of even numbers. So we will just print the number of even numbers in the following way. For I is equals to 1, I is less than of n by 2, less than equals to n by 2, and I plus plus, see out I into 2 and space. So for n is an even number or n is an odd number, it doesn't matter on the count of the even number, but it does match for the count of an odd number. For n is equals to 5, the total number of odd numbers is equals to 3, but n is equals to 4, the odd numbers is equals to 2. So but the even numbers in the both case are equals to 2 itself. So we should check for the two possible cases. For n is equals to for n is equals to n percentage 2 equals to 0, means if n is an even number, then we can directly print I is equals to 1, I is less than or equals to n by 2, I plus plus, both are the same. See out 2 into I minus 1. This is the formula for getting odd numbers from 1, 3 and so on. 2 into 1 minus 1 is basically 1. So 1, 3, 5 and so on we'll be getting. For if n is percentage 2 is not equals to 0, and if n is an odd number, then for int I is equals to 1, I is less than of n plus 1 by 2, 2. Say n is equals to 5. If n is equals to 5, then 5 plus 1 by 2, 6 by 2, 3. So 1, 2, 3. For 1, 2, 3, we'll be having 3 numbers and we'll be printing that. We'll be implementing the same formula, 2 times of I minus 1. So this small change we should do over here in order to make our code pass, because for the even numbers and odd numbers, the total number of count of odd numbers is not same. So that is the small change we need to do in this problem. That is the simple code for solution for this question. We'll be taking in, we'll be printing all the even numbers first, or we can do the reverse also. We can print all the odd numbers first and we can print all the even numbers later, or we can print all the even numbers first as implemented in this code, or we can print all the odd numbers in the later solution. So this is the solution for this problem. Now let's go to the next question. This is the number spiral question. Basically the number spiral, this kind of spiral is very famous, and it's implemented like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in this way it will be increasing so on iteratively, and we will be asking I comma j index, and we will be returning what is the element in the I comma j index. So that is a simple definition of this problem. You can see input, the first line contains an integer t, the number of tests. After this there are t lines, each containing integer y and x. For each text we print the number in the row y and column z x. So in the brute force way, what we can do is to implement the entire array number spiral till the given till the taking the max of y or x. Suppose in this problem it's given 2, 3 queries, 2, 3, 1, 1, 4, 2. So the maximum y or x is 4. So till 4, 4 array we can implement all the array, and we can return the corresponding element very easily by checking from the array. But it is absolutely a wrong way to solve this problem, because x and y limits tends to 1 to 10 to the power of 9. So it's impossible to implement a 2D array of 10 to the power of 9 times 10 to the power of 9 times, and we need to pass this problem in 1 second itself. So it is indeed impossible. So in a that is also for not one query. The t can be 10 to the power of 5. So 10 to the power of 5 into 10 to the power of 9 into 10 to the power of 9. It's way longer. So in a simple way we will be implementing a mathematical model for this question. Here luckily we will be having a pattern. In the pattern, what is this means? So for an n 1 comma 1 is 1, 2 comma 2 is 3, 3 comma 3 is 7. So here we can we'll be having two kinds of values, n is equals to even or n is equals to odd. For some even numbers 2 comma 2, 4 comma 4, the ending point, the max point is at this position, and for n is equals to odd 1 comma 1, 3 comma 3, the largest value is at this position. So we will be, I think it's gone. So we will be implementing this one matrix. So we should divide this entire into 3 things. So here say x comma y, we need to find what is the value in this one. What we need to do is, because it is like a square is extending to so on. So 1 comma 1 it's 1. So 2 comma 2, for 2 comma 2 the max element over here is 4. For 3 comma 3 the max element over this level is 9. 1, 4, 9, 16 and 25, and so on. So we can definitely give guarantee that for the previous element, the max element can be the following. So x comma y is there, so we can take max of x comma y. So the inner square as shown here, the inner square area will be max of x comma y whole square. So this is the area, sorry, x comma y minus 1, max of x comma y minus 1 whole square. Say for example, if it is 3 comma 2, then the inner square area is 3 minus 1 whole square equals to 4. If we check, it is a correct only. 1 2 3 4 5 6 7 8 9, right? Number square. So here 3 comma 2 is this one, and the inner square is this one, and the max element is this one. And if 3 comma 2 may, if this the large element, if it is 3 is not a multiple of 2, percentage 2 is not equals to 0. If it is not a multiple of 2, then the element at here will be the addition of the y, the column 1. Say 3 comma 2 is there, right? So here 3 is not a multiple of 2 equals to 0. Now we need to check if it is not equals to 0, then the answer, the element equals to the inner square plus the y axis, the y coordinate. This is a mathematical modeling. This entire question is mathematical modeling. It simply comes from the observation only. That's it. So for the 3 comma 2, the inner square is, the max element of inner square is 4. So and 2. Now 3 is not a multiple of 2. So basically the max value will be over here. And if 3 is greater than 2, if 3 is greater than 2, if this row is greater than 2 column, then we should check if whether this one, we can directly show this in code, that will be better understanding for you. Yeah. So in this question, first, if y is greater than x, and we'll be doing one thing, we'll be taking the value y and x, ll of y, ll of x. Ll means long, basically y can long adds to 10 to the power of 9, so ll of y and ll of x. If y is greater than x, if row index is greater than the column index, then we'll be taking the answer is, this answer is initializer to the inner square area, y minus 1 whole square into y minus 1 whole square, and we will be having, and we need to add some count, add some number to the inner square, and that is the output we should return to, or we should print in this question. So y percentage 2 is not equals to 0 means if it is an odd number, the max, if the row index is greater than column, and if the row index is an odd number, then we can guarantee that the max element will be in the topmost column. We can show you here. So here, for the row which is equals to an odd number and which is maximum, then the max element always lies in the top way. It is in the top column, top row. So we need to use this thing. We need to add the particular column to the answer initially, to the inner square max. So what we need to add is the x. X is the index of the column. Say 3 comma 2 mein 2 we need to add to the 3 minus 1 into 3 minus 1 whole square. 3 minus 1 whole square means 4 plus 2 is 6. So that is what we need to add. If it is not the case, if y is a multiple of 2, then the max value will be in the first column itself. So in this case, the formula is add is equals 2 times of y minus x. This formula is also getting by using a trial and error method only. By checking the mathematical modeling, we can get this formula. If we substitute this formula in it, we'll be getting the same results. Say for example, it's indeed instead of 3 comma 2, if it is say 4 comma 2. So if it is 4 comma 2 means you can go to task. So for 4 comma 2 means is 15 1, right? So the for 4 comma 2, the inner square is 9. So what we need to do, add 9 plus 1 2 3 4 5 6. We need to add 6 to the 9. So how can we get 6? 2 times of 4 minus this column 2. 4 2s are 8 minus 2 is 6. So this is how we need to add. This is obtained after doing some careful observation. That's it. It doesn't need to do anything else, that thing. So that is the formula. If y is greater than x means the row index is greater than the column index, then we need to take the area of the inner square, y minus 1 whole square of y minus 1 into y minus 1. Then what we need to add to that inner square, if y is an even number, then we need to add 2 times of y minus x. If y is an odd number, then we need to add just the column index. And what we need to return or what we need to print is the area of the inner square plus the thing which we need to add. So and else may the same if the y is less than x, then just we need to swap the x and y indices, then we will be getting the same answer, and the same formulas also the same. So see out answer plus or add. So once we can check this for the implementing one thing. Say for 4 comma 2, 4 is the max of 2, right? So 4, the inner area is 4 minus 1 into 4 minus 1, which is equals to 9, and 4 percentage of 2 is equals to 0, and hence what we'll need to do is 4 percentage 2 is equals to 0, right? So 2 times of 4 minus of 2 is the column 1, is equals to 6. Now 9 plus 6 is the C out. 9 plus 6 is equals to 15. So if we check in the question, 4 comma 2, 1 2 3 4, 4 comma 2, 15. So first suppose 5 comma 2, we will be having same. 5 is the max element, 4 minus 1, so 4 into 4, 16, and 5 is not a multiple of 2, so we just need to add 2. 16 plus 2 is equals to 18. We need to print this thing. If we check this is 5 comma 2, is it 18 is the answer for this 5 comma 2 index. So this is how the mathematical modeling is worked in this problem. And once again I will show you the code for this thing to have your look. So this is how this code is working. So this is what this code is, and this is we initialize it. We'll be taking n integers, and a we'll be taking integer in n, c in n, while n minus minus, int a and int b, c in a b, as we have initialized ll as l for here. So this is what this question is, and we'll be going towards the next question, 2 knights. This problem is also a direct simple mathematical modeling. So in this problem, what is your task is to count for k is equals to 1, 2 up to so on n, the number of ways two knights can be placed on a k cross k chessboard so that they do not attack on each other. So basically we'll be having a k cross k chessboard. I will explain it in one word. Yeah, so we'll be having a chessboard over here. Chessboard is the standard thing, not, it's an n cross n chessboard, and n is given by the input. He'll basically giving n 1 2 3 so on, and he will be giving, say example, he will give an 8 as an input. Then we need to check for all the values of 1 2 3 4 5 6 7 and 8. For all these values we need to check whether how many possibilities are there. So the simple mathematical modeling of this question goes like this. Basically, if we're having n cross n matrix A, n cross n, this is a square actually. So for the first knight, how many values will be having? N square. For the second knight, how many squares will be left with? N square minus 1. So in total, n square into n square minus 1. As both are identical, we'll be dividing by 2. So these are the total possible pairs which are possible in an n cross n chessboard for two knights. And out of these squares, there are some specific squares such as 2, 3, 2 cross 3 and 3 cross 2. 3 cross 2. So if it is here, if k1, k2 and k1 dash, k2 dash. So here there will be two pairs of conditions. Here k1 and k2, instead of drawing two rectangles, I have drawn only single rectangle. There for this 2 cross 3 we will be having two possible alterations such that this particular 2 cross 3 value, this thing can be a case which is not in favor of the answer. So we need to remove these things, and we need to check how many such kind of squares are possible, how many such kind of rectangles are possible, and we need to count all of those iterations, and we need to subtract from the total n cross n and total this thing. For this thing also, k1, k2, for your clarity I will draw it again here instead of making it over above. K1, k2, and the reverse is the basically the same thing. So here also two possibilities. So for an n cross n board, how many 2, 3? This is n cross n, 1 2 3 so on and so on. For an n cross n, how many possible? 2, 3. But first taking 2 for this thing, say if taking this taking this 1 2 3 4 5 6 and so on. So basically the totally for two columns we can select in n minus 1 ways. For 2 rows we can select in n minus 1 ways, and 3 columns combined we can select in n minus 2 ways. So total we can multiply with n minus 1 into n minus 2, and the same comes for the 3, 2. 3, 2 also we can select this thing 1 2 in similar way. So 1 2 3 4 5 minus 2 3. So there are 3 possibilities of this thing. This is one thing, this is second thing, this is third thing. So in the similar way, here 3, and for 2 columns, this is one thing, 2 column, this is second thing, this is third one, this is fourth one, because there are 5 minus 1 4. So total 3 into 4 3 cross 2 are present. In a similar way, the total n minus 1 into n minus 2 into 2 colors, like 2, like 3 cross 2 and 2 cross 3 into 2, because for each configuration there are 2 possibilities of an unfavorable knights locations for knights. So we should remove this total count from n square into n square minus 1 by 2, and this minus this is the answer for this question. So that's it. So the core idea is to find that this 2 comma 3 and 3 comma 2 will be having 2 configurations for each of things, and for implementing of this thing we need to run n minus 1 into n minus 2 for this one and this thing. Once you draw this in your own pen and paper, then you will get to understand how this count will be correct and accurate. So the same thing is implemented in the code also. The code is very simple for this question. It's a single line code indeed. So we need to check, and yeah, for n is equals to 1, basically for if it is only, if there is only one block in the board, then how can we insert 2 knights? So that is basically total unvalid for move. For n is equals to 1 we need to return 0, and for n is equals to 2 also there is no possibilities of any kind of 2 comma 3 or 3 comma 2. So we can directly count, and it is 6. It is also given in the example which is discussed also. So for n is equals to 2 we need to return 6. If n is equals to 1 we need to return 0. For n is equals to, which is greater than 3, then we need to do this thing. Answer is equals to 1, n square is n cross n, so return n square into n square minus 1 divided by 2 minus 4 times of n minus 1 into n minus 2. We need to return this thing in this return, or we'll be printing over here anyways. C out of get of I is equals to 1 till n. We'll be taking n as an input. So this is the simple code for this problem. This is simple mathematical modeling. The last question, the Queen's question, and this question both are the mathematical modeling only. Coming to the next question, 2 sets. In this question, it's also similar to the previous one. Here what we need to do is, your task is to divide the numbers 1, 2, 3 up to so on n into 2 sets of equal sum. We need to return 2 sets from the 1, 2, 3 up to so on n numbers into 2 sets of the equal sum. So basically what we can do is, here it requires a small thinking. After thinking for a while, we can get easily to the problem. So basically 1, 2, 3 up to so on n numbers are there, and we need to return it, make this into 2 halves. As given an example, it's 7, right? So 7 के लिए 1, 2, 3, 4, 5, 6 and 7. 7 is divided into 1, what I will say, 1, 2, 4, 7. 1, 2, 4, 7. So 1 plus 2, 3. 3 plus 4 is 7, and 7 plus 7 is 14, and the other group is 3, 5, 6. 3, 5, 6, and 5 plus 6 is 11. 11 plus 3 is 14. So both are equal, right? So these 2 sets, in the similar case we need to return 2 sets such that the sum is equals to equal. How do we do this question? It is very simple. First we need to check whether it is possible or not. So what we need to do is, we need to have total count. What is the sum of n numbers, n natural numbers? It is n into n plus 1 by 2. So if this is an even number, if basically the total sum is even number, then only it is possible. Otherwise it is not possible, and we just simply return false. because it is not possible. Here it is said that if it is not possible, return no otherwise. So we just first need to calculate n into n plus 1 by 2. If it is an even number, then we can for sure we can divide it into two sets. And if it is an odd number, then we can't divide, because for example, if 6 is there, for 6 into 7 by 2 and 3 equals to 21. So the 21, if we divide by 2, it is 10.5, but we are having only natural numbers, so it is impossible to make a set of the sum equals to 10.5. So this is basically we need to return no. And so okay, if it is an even number, so how do we divide? We will be using a small kind of technique over here. What we'll be doing is that we will be taking half of the total sum. Total sum is, for example, for the case of 7, the total sum is 14 into 2, right? 28. So for the total sum for 7 number, total sum is 28. So we need to have 14 for one set. How do we do this? So what we'll be doing is we'll be taking the max element. Initially the max element is 7 itself. We will be taking a max element. We will be adding to set 1. S1 is there, S2 is there. We will be taking max element and we will be adding to set 1. And we will be increasing, we will be making another variable which has the sum of all the values in set 1. And say sum S1 equals to 7. Now what is the left value? Left value is equals to 14 minus 7 is again 7. So once 7 is used, now there wouldn't be any other 7. So what we'll be doing is that we will be adding the next max element to the S1. Next max element is 6. So we'll be adding the next max element is 6 to S1. Now what will be the sum now? 7 plus 6. Sorry, there's a small error here. Basically what we'll be doing is that we'll be checking the left. So how much is left for the 14 of once we add 7 is the left is equals to total 14 minus 7, which is equals to 7, right? So the left value is 7. So is this 7 is this? It is not there. So we need to add the max element from here. So, yeah, there is no wrong. So we need to add 6 to the S1. Now what we'll be having, there is no error in the, I just confused with something else, so it's fine, it's correct only. So we should add the next max element to the S1, because the left is greater than the max element in the current set, max element possible 6. Now what we'll be having is 13. Now what is left? Left is equals to 1. Now the max element is 5. We can decrement each and every time 5. So if we compare the left and the max element, if we add this max element to again set 1, then the value will be increasing from 14. It will be overshooting. So we should stop from here, and we just need to add this left element into the S1, max 1, S1. So if we add this 1 to S1, then we will be having 7 plus 6 plus 1, which is equals to 14. So this is how we got set 1. And the remaining elements 2, 3, 4, 5, we can add these to set 2, such that we can get 14. In the simple way, we can do every operation in this question. So the pseudocode or the operation, basically what we'll be doing is we will be adding max element, the max element to set 1, and we will be maintaining the left sum, and we'll be maintaining a left value kitna baki hai. So if the left value is greater than the max element, then we will be adding the max element to S1 set. If until and unless left is less than max element. If once left is less than the max element, we will be adding left element itself to max element to set at S1, and we will be adding remaining elements remaining all to S2. So this is how the logic behind this code works. Now once I will show you code, you will get understood. You will be more clear for this one. Two sets. Yes. Okay. So it's look like a big code, but it is nothing here. That is for sure. So for int n, we'll be taking the n value, we'll be calculating the total value and into n plus 1 by 2. If total percentage here, total percentage 2 is equal not equals to 0, means it is an odd, the total is an odd, then we'll be returning no. Else if the total is an even number, then we'll be returning s first. Then we should actually print, right, the two things. So we will be maintaining two vectors, set 1 and set 2. We will be maintaining a hash map such that we will be able to know what is present in the set 1 and what is not present in the set 1, right? So we will be maintaining hash map such that whenever we pushed any element in the set 1, we can mark either true or either false in the hash map, so to make a difference. Initializing some variable to 0 and initializing max element possible here equals to n itself. So while sum is less than total by 2, sum means sum which is present in the first set. I'm doing entire operation in the first set, such that after creating the first set by using the hash map, we can directly create the other elements. We can push the other all elements which are remaining in the hash map into the set 2. So that's why nothing specifically sum of set 1 I'm doing nothing. So basically directly simply int of sum is equals to 0, max is equals to n, while sum is less than total by 2, half of the total. Int left is equals to total by 2 minus 1. How much is left? कितना बाकी है पूरे होने के लिए? If the left is greater than max e, we can't directly include the max. 14 initially were having with only 7. So if left is greater than max e, then we'll be adding max element to the sum, and we will be marking the visited of maxi to as 1, and we'll be pushing the maxi to the set 1, and we'll be decrementing the maxi because once we have added 7, we need to make the maxi to 6 because 6 is the next greatest element. So maxi decreased. So this operation continues till while left is greater than maxi. Next, else if left is less than maxi, say now in our previous example, if left is equals to 1, set 1 dot pushback of left, visited of left is equals to 1, sum is equals to total by 2. This is obvious. So now sum is equals to total by 2, sum is less than total by 2 is the condition. It is failing, we will be coming out of the loop. So we will be and coming now the set 1 is completed. Now we will be checking what else in the visited array which are not yet visited. Visited of I is equals to 0, where I belongs to 1 to n. Set 2 dot pushback of I, if it is equals to 0, means if it is not visited, which is not in the set 1, we will be pushing to set 2. Now we will be printing what is the size of set 1. We will be printing all the elements in the set 1, and we will be printing the size of set 2, and we will be printing the all the elements in the set 2. So this simply we will be doing this thing. So main thing is the left is greater than maxi, so I will be adding the elements, the max element to the sum. We will be pushing the max element to the sum unless and until the left, which is the total left sum, which is less than the maximum element in the set in the given range. Then we will be including the left into the array itself, into the set itself, and we'll be closing the count, closing the loop. So in this way we will be implementing this question. This is once first time it will be a little bit harder. Once we understood by a clear example, then we will be getting it's very easy. So this is how this question two sets is. Now bit strings. So after if in compared to the number spiral and two nets, two sets is a little trickier question because we need to think a little bit as compared to the two nets and number spiral. It's just mathematical modeling. In this question, this is the simplest question. We just need to return that power 2 to the power of n. So first the question is, the task is to calculate the number of bit strings of length n. So if for example n is equals to 3, the correct answer is 8 because the total possible bit strings 0 0 0 0 1 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. So for n we'll be having 2 to the power of n bit strings. That is simple. For n is equals to 0 itself, 2 to the power of 0, for n is equals, n belongs to 1, right? So n 2 to the power of 1 is equals to 2, 0 1. For n is equals to 2 we'll be having 4. For n is equals to 3 we'll be having 8. For n is equals to some 10 we'll be having 1024. So in this way what we need to do is, we should not directly implement power because it may overflow. What we need to do is, we need to implement binary exponentiation over here. Binary exponentiation is a simple code. So we need to use this binary exponentiation. Basically this is the small code, this is a simple way of so what exactly is binary exponentiation means? It's like for an odd number, for say 2 to the power of 8 is there, so 2 to the power of 8, so we'll be incrementing 2 to 4, 4 to 8, and 8 to 16, and so on. And at the same time we'll be decreasing 8. Initially it is 8, right? So 8 to 4, 4 to 2, 2 to this thing. Like we'll be decreasing the power, and we'll be increasing the original value which we need to implement. And wherever the power becomes an odd number, then we need to add that particular number. We need to make that number into the array. Here everything I've considered is an even, so 2 to the power of say 5, 2 to the power of 10, that is nice, 10. So initially 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Here initially it is 10, it is 5, it is 5 by 2 is 2, it is 1. So in this way we need to make sure we need to divide these two things, and wherever while n will be in passing this n, and easily pass it as 10, right? So if 10% of 2 is not equals to 0, here 10% of 2 means 10 is divisible by 2, yes, it is equals to 0. So we don't need to do this thing, we just need to multiply. Value is equals to value into value, means value is 2 here, base 2 into equals to 2 into 2 means 4, percentage of mod, and n is equals to n by 2 means this case. We still not included any kind of into the output answer. Now from here we came to here. Now 4 comma 5 is the current. Now if we see, the 5 is an odd number, right? Here n percentage of 2 is not equals to 0, yes. Now we are including the value into the answer. So from the to the answer we will be including 4. Answer initializer as 1, so 1 into 4 we will be including an answer. Answer is equals to answer into val percentage of mod. Answer is equals to 1, answer is equals to 1 here 1 into 4 percentage of mod, answer is equals to 4, and value is again increase it to 12. We will be squaring it again, n is equals to n by 2. So from 4 to 8 we will be counting here. Now we will be moving from here to here. Now we have noted having 4 in the answer. If you check, so again we will be moving from here to here because 2 is an even number again. We don't need to do anything. Now we got an odd number. Now after getting odd number, what we need to do is, well, n is equals to 1. Value is equals to value into val. Yeah, value is equals to value into the val percentage of mod. So what we'll be doing is, here here it's not actually 8, sorry, there is a small mistake over here. It's not 8 over here, sorry, it's 4 square, value into value. 2 into 2 is 4, 4 into 4 is 16, 16 into 16 is 256. So this value is 256, sorry, pardon me. So it's value into value. Here you can see its value is equals to value into value. Because this is of 2s, I confused with 2, 4, 16 and 256. Here it is 1, it's 1, 2, 5, 10. Yeah, so we have included this thing. Now we will be again including this thing. So answer is equals to ans into 256. So answer initialized as 4, right? 4 into 256 is 1024. Here what is the we'll be having this thing very fastly and a little bit more accurate than, because at every step we'll be making a modulus over here. So binary exponentiation means we will be multiplying the answer value only at the 2th powers, such that the total time complexity will be very much less as compared to the O of n. It will be like log of n base 2 as compared to n, O of n in the normal for loop. As compared to for loop, binary exponentiation is too much faster. We have an that's why wherever we'll be dealing with the largest powers, we'll be using binary exponentiation over here. So this is a standard code. Binary exponentiation is very famous, and this is a standard code for binary exponentiation. So be long and we'll be initializing long answer is equals to 1, value is equals to 2, and here it is for the as base is always fixed, we'll be taking only to what power 2 should be raised. Otherwise binary exponentiation is normally binary exponentiation of int x comma int y comma int mod. We'll be giving mod also, while x percentage is not equal, while x percentage mod. So in the similar, in that goes in that way. So long answer is equals to 1, value is equals to 2, answer is equals to answer percentage of mod, while n, here n percentage of 2 is not equals to 0. If n is an odd number, then only we will be having this answer value mod 0. When n is odd in bit representation, basically we will be encountering 1s over there. Whenever n is equals to odd. So for suppose 10 can be represented as this thing, right? Sorry, 10 this is 9. So for 1 0 1 0, 10 can be represented as this thing. By dividing by 2, we will be shifting towards one thing. By dividing by 2, 1 0 1, this first bit is an 1. That's why we are multiplying the current multiplied value to the answer. Again we will be multiplying it by 2. Now it becomes 1 0, this is 0, we don't need to multiply, it becomes 1, again 1 is there. That's why we'll be multiplying the current the squared value to the answer. So this is another explanation for the binary exponentiation. In from here the name binary came. 1 0 1, the bit representation, wherever there is a 1 for the power, then only we'll be multiplying. Otherwise if it is 0 and bit representative, will not be multiplying. So that's how it's cutting. This is the standard code for this binary exponentiation. So answer is taking an n value, c in n, and c out a binary exponentiation of n and endl. That's it. This one line code and this binary exponentiation code. So this is the explanation for this question. Next, going to trailing zeros. This trailing zeros is JE level, JE type. In the JE days, we'll be having one question in permutation, in the combination. Basically in the combination we'll be given an n factorial, 20 factorial, n factorial. Say in our days it's 100 factorial mein kitna zeros hai ending mein, like that, 20 factorial, and we need to find how many zeros at the end. Basically for a zero, it's very famous question in JEs. So for a 0 in n factorial, for zeros, we should have for any number n, if represented in 2 to the power of m and 5 to the power of k into some other values to the power, we'll be having always m greater than k. So we will be having zeros, the k times of zeros. 2 times of 5 is 10. For 1 0, we need to have 1 power to the 2 and 1 power to the 5. So here, as numbers exist as the for the any natural number, basically always m will be greater than k. So if we find the count of k, then the k is the answer for this problem. The k times we'll be having, for example, say we'll be having, so take 620 itself. So for the 20 factorial, how do we find this count? There is a simple formula: 20 by 5 plus 20 by 5 square plus 20 by 5 cube, and so on. That goes so on. Here it's, and this is the this is the from this equation we will be getting the 2 to the power 5 to the power of k, the k value. The value of k we can get from here. For getting the value of m, the same formula exists: 20 by 2, and this is a HGS approximation, and 20 by 4, 20 by 8, 20 by 16, 20 by 32, so on like this. If we observe clearly here itself, it is the answer is 10. And in case of 5 square is 25, it's greater than 20, so all these things are 0. We don't need to do anything here. 0, it is big 0 here it is 4. So if we observe, if m is greater than 10 itself, m is greater than 10 and k equals to 4, so the answer is the number of zeros in the factorial of 20 is equals to 4. That is the answer in this case. 20 factorial is equals to 2 something, and the last thing is 1 2 3 4, 4 zeros, has 4 trailing zeros. So this is how we need to find for every given answer. So we don't need to do anything for getting the power m, because every time m is greater than k, we just need to find k. How will be finding k? The same formula. We will be implementing the same formula in the code. So if we see the code over here, so IO is best, sync with studio, stdio, sync with stdio. So we'll be taking n if count is equals to 0, initializing the count to 0. Int cur is equals to 5, we will be taking the current is equals to 5, while cur is less than or equals to n, means that particular thing. If while cur is less than or equals to n, count plus equals to n divided by cur, n divided by cur. So if we take n as an 20 factorial, so 20 divided by 5 is equals to 4, right? So count plus 4, and now cur will be becoming 5 into 5, 25. Now 25 will be less than 20, so we'll be coming out of the loop and we'll be printing 4 as the answer. In a similar way, for any n, for suppose n is equals to some 200, so 200 will be having 200 by 5 some value, and later 200 by 25 and another value, will be adding that to the count. 200 by 125 will be adding to another term, and 200 by 625, that is 0. So we'll be stopping over there. So we'll be having 3 times of iterations, and we will be adding to the count, and we will be printing count at the end as an answer. So that is the code for this thing. It got accepted. Every code I'm showing is accepted only. That's why I'm showing from here, such that you should not get any doubt whether the code is accepted or not. So this is the code for this question. And next question is coin piles. Sorry. So what we will be doing in this question, yeah, it's also a little bit of mathematical modeling, but it's simple mathematical modeling. It is not that difficult from the previous things, such as that number, grid, and that particular stuff. So here basically what you're having is you have two coin piles. We have two coin piles. Piles means a small collection of coins. Two coin piles containing A and B coins, like A and B count of coins. And on each move you can either remove one coin from the left pile and two coins from the right pile, or two coins from the left pile and one coin from the right pile. So your task is to find if you can empty. If that means we need to return yes or no type of question answer as an output. If you can empty both piles, the first input line has an integer t and the number of tests. After this there are t lines, each of which has two integers a and b, the number of coins in the piles. So these are the test cases. So basically how do we do this? If we do brute force as we have done in the first question, that weed algorithm question, then we are gone, because it is t is 10 to the power of 5 and a and b are 10 to the power of 9, so it's basically impossible. It's a simple mathematical modeling we can do over here is, say a b. Now if a plus what if we check the answer, if 2 comma 1 2 comma 2 3 comma 3, right? 2 comma 1 2 comma 2 3 comma 3. So if 2 comma 1 means as we can remove two coins from the pile 1 and one coin from the pile 2, we can make this 0 comma 0 in one operation itself. For 3 comma 3 we can remove 2 comma 1 first in the first operation, that will be making 1 comma 2 is equals to 1 comma 2, and after minusing 1 comma 2 we will having 0 comma 0. So from the given example observation, in 2 comma 2 we can't do anything here, because once we have removed either 1 comma 2 or 2 comma 2, we will be getting 1 comma 0 or 0 comma 1, which we can't do anything for this, so it is not possible, no. So from this observation, what is, if a and b are given, if a plus b percentage of 3 equals 0, then that is possible. And this is another condition. What is, a should less than or equals to 2 times of b, and b should be less than or equals to 2 times of a. This both conditions should follow, because say if it is like so say 4 comma 5, if it is 4 comma 5, then the total sum is equals to 9 and equals divided by 3 is equals to 3, right? So what we need to do is say 1 comma 2, if we remove from here, it will be having 3 comma 3. We'll be having 3 comma 3, and the 3 comma 3 is already checked, so it is equals to 0. But for some cases, say the sum is a number which is divisible by 3, but there is huge difference between a and b, then that indeed is not possible. Say 1 comma 8, say for this 1 comma 8, the sum 1 plus 8 divided by 3 is equals to 0. Yeah, that's true, but once we have done one operation, say 1 comma 2 we have removed from this here, it will become 0 comma 6, and this is not possible, this is not possible. So what we should do is, but here there is a chance, if this is half of this thing, means say a, and say for example a is equals to 3 and b is equals to 6, 3 6. Here if it is exactly half of the thing, then what we can do is, we can implement 3 times 1 comma 2, we can decrement, and the result will becomes 0 comma 0. So this is the max possible deviation from a and b. So that's why either a should less than or equals to b, and b should less than or equals to 2 times of a. This condition should also satisfy with a plus b percentage 3 equals 0. If these three conditions are satisfied, then there is an answer and we should return a yes, otherwise we should return no. So that is a simple case. And why is this thing? As 1 comma 2, 2 comma 1, 0 comma 0, 3 comma 3, all these are possible solutions. If we check here 1 plus 2, instead of checking 1 plus 2 and 2 plus 1, 0 comma 0, 3 comma 3, we directly checking a plus b percentage of 3 equals to 0. Instead we can also check like a percentage 3 if it is equals to 1, and a b percentage of 3 equals to, this is one case, and we should check for this thing. So instead of checking these redundant things, we can simply make a plus b percentage 3 is equals to 0, and a is less than equals to 2 times of b is less than equals to times of a. If all three conditions are satisfied, then return yes, or else return no. So this is the simple question, yes no implementation. This is a one line code solution. It looks like big, but it's simple. It's a one line solution. See, while n minus will be taking n, and queries will be taking two integers, int a, int b, c in a, c in b, and if a, same I have implemented here. If a plus b percentage 3 is equals to 0, and a is less than equals to 2 times of b, and b is less than equals to 2 times of a, then return cout equals to yes, else cout equals to no. Check if total stones can be divided into pairs summing to 3. So this is how the code is. Sorry sir, what's gone? Yeah, so this is the code. So this is the code for this question. Yeah, so now going to the palindrome reorder. I'm not checking the time, sorry if it is going wrong more. So palindrome reorder. So given a string, your task is to reorder its letters in such a way that it becomes a palindrome, that is, it reads the same forward and backward. So this is again a very simple question. Only input line is a string of length n consisting of characters a to z. Print a palindrome consisting of characters to a original solution. Maybe print any valid solution. If there are no solutions, then print no solution. So here basically what will be given is a string. Will be given a string of VBCD values, and what will we need to check is what we need the output is a palindrome, if it is possible. If it is not possible, we need to return a no solution is as an answer. So it's given 4a CAC BA. A C A C B A. So what we will be need to do is we should make a hash map first. Hash map, and A are having 6, C are 2, B is 1. So first of all, what we need to check is if the total number of odd occurrences of any character is greater than 1. If total number of odd occurrences is greater than 1, then we should return no solution, because it is impossible if we have two occurrences of two odd occurrences of elements. Say here in this case only 1 is there, b is equals to 1. So if a b c d is there, a b c b is there, it is possible as this thing. But if a b c d b a, if it is there, now we have two odd occurrences of c. Odd occurrences means the count of the character is an odd number. If there are two such characters whose if the count of the characters is greater than, which is odd, is greater than 1, then there is no solution for that particular string. That is the basic solution for no solution case, base case. And in the alternatively, we can have, if it is not the case, we have only one odd occurrence, then we can for sure divide the string, and we can rearrange the string, and we can implement the palindrome from the string. In which way? Basically, first suppose in the way there are so many ways, and what I have implemented is first taking a count. It is having 6, right? So having 6, so we can initially implement a string of length, and value having length, and we can keep 6, right? So once for one time we can keep the character a in the starting and a in the ending, while the count of a is greater than or equals to 0. So after we have used two occurrences, we need to decrement by 2. Minus 2 equals 4. Now the value of the hash value of a is again greater than equals to 0. So we can again implement a in the once in starting, once in the ending, and we can decrement by 2 again. Again there is a 2 hash, again we can increment a, and we can minus decrement by 2, so equals 0. So we can go to the next one. It is C. No, it's B, right? So B has a value of 1. So for this well, as we already know that there would be only one occurrence of a NOT, so we will be decrementing the count of B by 1. Now it will become 0, and string of n by 2 equals to that character. We will be making the B as the middle one, and C has 2 count, right? So we'll be implementing C as this C here and here, and minus 2 equals to 0. So basically A, C, B, C, A. This is the output string which we have done from our operation. Once you have C in the code, you will get more understood. So I will be showing you the code. One sec. It seems like a little bit code. It's very easy. It's simple only. So first we will be taking string s. Int n is equals to s dot length, string answer of n. So we will be initializing the string with all spaces. We can initialize with nothing also. We can initialize with anything literally. But it's first the namescape we have initialized with a space. So frequency map, we will be making a frequency map of 26 for every occurrence of a string. For every character in the string, we will be incrementing the frequency map for the every occurrence of every string in the frequency map. Say int sound is equals to 0, frequency of s of I minus of a is plus a equals to 1. So this is a hash map implementation. Next, int c count equals to 0. What is this count for? The counting the odd occurrences. For int I is equals to 0, I is less than 26 for all the characters, I plus plus. If frequency of I percentage 2 is not equals to 0, means if there is an odd occurrence, then count plus 1 equals count plus 1. If count is greater than 1, then we need to return no solution. That is an impossible to make a palindrome. So count is greater than 1, the total number of odd occurrences is greater than 1, we need to return no solution. Else we will be initializing, we will be creating the palindrome here. So how will we already initialized a string with a length n, and every element of the string is just a space, or we can just keep anything space. So we will be initializing 2 pointers, left, right. As soon as we will be going, so as we will be going to all the throughout the hash map, we will be incrementing the left and we will be decrementing the right. So for int I is equals to 0, I is less than n, I plus plus means all the characters. If frequency of frequency of that character is equals to 1, if it is a NOT, then answer of n by 2 will be noting that particular character in the middle of the string. Answer of n by 2 equals to s of I. Frequency of s of I minus of a minus equals to 1. Minus equals to 1. So frequency of s of I minus a minus equals to 1. We will be decreasing the frequency by 1, and we will be making the we will be noting the character in the middle of the output answer. And while frequency of s of I minus a is greater than 0, we will be incrementing answer of left plus plus and right minus. These are post incremental, like after the evaluation of this particular equation, then the corresponding value will be incrementing. It's not pre-incrementing, it's post-incremental. So left plus plus means answer of left equals to answer of right equals to s of I. Once this thing is done, then left will be increasing by a 1 and right will be decreasing by a 1. So that is the code here. And frequency of s of I minus of a minus equals to 2. Here frequency of s of I minus a is done because basically a is represented as an ASCII code. So for an a will be having one particular kind of ASCII code, a b c d till z will be having a consecutive ASCII codes. That's why by decrementing the particular string with a, we will be having 0 if it is a, if it is b will be having 1, if it is c will be having 2, and so on till 25, because it starts with 0 indexing. So this is the main portion of the code. Else, like else means cnt is not equals to greater than 1 or greater than 1, then left is equals to 0, right is equals to n minus 1, and we will be traversing through the entire given string. If the string has a count greater than equals, if it is an odd count, then we will be noting that character in the middle of the string. If it is an even count, or it doesn't matter if it's odd count or even count, if the count is greater than 0, then we will be decrementing the count by 2, and we will be putting that particular thing inside once in the starting and once in the ending, and we will be incrementing the left index, we will be decrementing the right index after the evaluation is done. And at the ending, so left will be equals to n by 2 minus 1, and right will be equals to n by 2 plus 1, or both are equal. It can also happen. Yeah, it will both will be equals to n by 2 n by 2, and we need to return answer. So we need to return answer as an output. So this is what we will be doing in this question. Sorry, once. Yes. Sorry for the disturbance. Yeah. So this is the code for this question. Now next code, gray code. Gray code is also very simple. This question is the code is very beautiful written by me. The code is like, after thinking a lot, I've get very simple thing. So gray code means it's basically gray code means we'll be having some binary sequences, and every consecutive element of this binary codes will be differ by only one Hamming distance of every pair. Every consecutive pair has a Hamming distance of 1. Hamming distance means if we XOR all the elements of the pair, and the XOR value will be returning only 1. So that is, for example, here output may 0 0 0 1. For this thing, the Hamming distance is 1 because only one change is there for this entire string. So what we'll be doing is, I will explain. So we'll be starting with 0, n is equals to 1 means only 2, like only 1, 0 and 1. Now if n is equals to 2, how we'll be incrementing? What we'll be doing is, we will be pushing. This is the vector, right? Vector starting. We will be pushing same in the reverse order, 1 0. We will be pushing from the reverse order, and for the upper hemisphere, like for the upper portion, we'll be adding 0 at the starting, and for the ending, for the half below this thing, we'll be adding 1. So if we check the output, 0 0 1 0 1 1 0 1. If we are careful observe, this is a Hamming code, this is the gray code, and every Hamming distance is equals to 1 1 1. So in a similar way, for n is equals to 4, if we take this 0 0 1 0 1 1 0 1, we need to do this. It's like a mirror reflection. So we can't say a mirror reflection, we can't directly implement anything like a reflection. That's why I am saying that more technically, we will be appending the same array in the reverse order. That's it. So 0 1 1 1 1 0 0 0, and we will be appending 0 for the upper things. We'll be appending 1 to the upper things, 1 and 0 will be 0 0 0 0 1 1 1 1. So this is the gray code for n is equals to 3. This is the gray code for n is equals to 2. This is the gray code for n is equals to 1. So in the similar way, we will be implementing the gray code very easily. So if the code is beautiful, so if we check the code, yeah, so initially GC means gray code, and we'll be taking n means the length. So gray code, while string GC we'll be pushing back nothing, so we'll be pushing back nothing. So initially I is equals to 0, I is less than n. This is like for n is equals to 0 means 0th iteration. For the first iteration means like the length of the bits, like n is equals to 2 means we'll be having the length of each string as 2, 0 0 0 1 1 0, like that. So for int size equals to GC dot size, here initial size equals to 0, right? There is nothing to do. For j is less than j is equals to size minus 1 to j is greater than equals to 1, j minus GC dot pushback of GC dot j means for the same array we will be pushing the elements from the last to first, from the reverse order we will be pushing. Now we will be having for j is equals to 1 to size minus 1, we will be having the original array, and for this j is equals to size to 2 times of size minus 1, we will be having the reverse array. And after making this implementation, we will be making changes in size into twice. But int j is equals to 0, j is less than size by 2 means after incrementing the size for the first original array, we will be adding 0 for every string. Because it is a string, we can easily add, or we can also use pushback function also, because it is a string. For string we will be having pushback function available, or we can simply add as if we are adding to a number. So GC of j plus equals to string of 0. For j is equals to size by 2 to j is less than size. Size is basically twice the initial, right? So we're not implementing any 2 times of size such stuff over here. So j is equals to size by 2 to j is less than size, j plus GC of j plus equals to 1. We're incrementing 1 to here. This simple code, and after making this loop done, I is equals to 0, we'll be making only 1 and 0. After this size equals to initially 1, right? This is 1, so size equals to 1, so j is equals to 0. This thing size will becomes 2 at the ending of the I is equals to 0. When I is equals to 1, it will become 1. So I is equals to 2, it will become 3, and this so on. For an I is equals to less than of n, I is equals to n minus 1, the total length will becomes n, because it is increasing for every increment. So after the entire thing, we will be returning for auto x belongs to gray code cout x as endl. This is the implementation of gray code, simple implementation of gray code. Next, Tower of Hanoi. This Tower of Hanoi is very this is a very famous mathematical modeling question. Basically, I will show you the game. So here, this is the Tower of Hanoi game. We will be having 3 rods like this thing, like this thing, and we need to keep all of these towards the last thing, and that is we can use this as intermediate thing. Basically, now we need to give the steps for this in this code. So he has given like 2. For 2 means the values are 2, like there are only 2 boards or 2 discs on the start position, starting rod. like here we can also run. In the Tower of Hanoi game consists of 3 stacks, left, middle, right, and round discs of different sizes. Initially the left stack all the disc in increasing order of size from top to bottom, increasing size of order. The goal is to move all the discs to the right stack. Using a middle stack, on each stack you can move the upper more disc from the stack to another disc. In addition, it is not allowed to place a larger disk on a smaller disk. Your task is to find a solution that minimizes the number of moves. The only input line has an n as the number of disks, and the output line is k, the number of moves. So we need to output the number of moves, and every move we will done 3 1 2 1 3 2 3. So once I've played this game, you will get very easily. So for 3 levels, basically the algorithm what we will be doing is that, now for suppose this like make this, okay, so for 3, if we do like this anything, now if we do here, now if we do here or here or here, so this is moves are 11. It is not an optimal moving. In optimal moving, what we should do is basically, now the green and the dark green and the pink light green, this 2 discs should be come to here, and this down disc should come to here, right? So in order to move the last ring to the final ending position, we need to move the above the n minus 1th thing to this position, and after moving this to the last position, ending position, we need to shift the intermediate, whatever which is the value in the intermediate, to the this thing. So this is the basic standard recursive formula which is used in this function. So in order to make this 2 green bar to this thing, we need to move this one to here, this one to here. This one, why I'm here, because if I need to keep this one to here, so I need to make the above one to here, and then I need to move here, so this one to here. Now easily this, there are 2 discs, right, the above green and below one. So above one, now this entire thing I should move towards here, right? So instead of moving anything like this, first I need to move this to this extra thing. Now we need to return this to the original, and then we should need this to here. So in this way we will be making this mathematical modeling implementation in recursion in the C++ code. We can play this one more level. So for the 4, for this yellow one to here, we need to make this some cement one to here, we need to make cement one to here, we need to make green one to here. So for green one to here, one, we need to make this one to here, this one to here, this one to here. We need to move this one to here, right? So for this one to here, this one to here, this one to here, this one to here, we need to remove this one to here, right? So this one here, this one here, this one here, this one here, and we need to move this one here, and this thing, and this thing. So the moves are 15 and the minimum moves is 15. So in this way, the if say the ground level is n, in order to move n from 1 to 3, this is 1 2 3, 1 2 3, 1 2 3, we need to move n minus 1th load to 2 to auxiliary position or the middle value, and nth position to the ending, and we should move the value in the auxiliary position, whatever thing, towards the ending again. That is the code. What is the basic mathematical modeling of this question? So if we check the code which are submitted, you will get to understand very well. The code is simple only. The simple recursion function, basic backtracking, simple thing. So initially we will be storing all the things in the moves. We will be starting with the source, src source 1, ending is 3, middle is 2. Now md means what we'll be doing is what move disk means int num will be having the number of disks, and the vector int moves, we'll be storing the moves over here, and src and middle. SRC means the source, and where from where we're moving to where we should move, and what is the middle value. So that is the thing. So we will be initializing the move disk with the end disk. It means the end disk will be moving. So the base case means if we will be having we will from the top one we have reached the bottom. We have reached the bottom. Now if number is equals to 1, we are in we have reached the bottom disk. Now what is the base case for the bottom? What we should do for the bottom? The bottom one should be moved from the 1 to 3, or basically src starting to end. That is what we are doing here, and will be written. That is the base case. We don't need to remove anything for here. So that is the thing. If num equals to 1 means the num means that the total number of the disk we are at currently is first the bottom disk. Num equals to 1, then moves dot pushback of src dot end. From the starting to ending we can directly push because there is no load above the thing, and we need to return. There is nothing above the particular thing. We're having only one disk we're remaining, and we need to remove that particular disk from starting to ending. That's it, and we need to return. We know what to do. And if it is not the case, if num is not equals to 1, then what we'll be doing is that we will be returning the md num minus 1 comma moves comma src comma mid comma end. What we'll be doing is that we will be moving the current thing from the current thing. We should move the n minus 1th disk, like, or the disk which is above the current level from starting to middle. And now if you carefully observe, starting is this thing, starting will remain same. In the place of end we got middle, and in the place of middle we got end. So that is the difference. The middle of n minus 1 comma moves src mid comma end moves, and after this thing we need to add. Now what we have done, we have removed the n minus 1 or the above button to the middle one. Now we can directly move the current step to the ending, right? So that's what I'm doing. Move push back after the md moves push back src to end, the starting to end. Now we have moved. Now after moving we need to backtrack, right? So md num minus 1 moves mid and src. What we are doing is we have kept something in the middle value, right? So from the middle value we should keep that entire thing to the ending. That is, so md of num minus 1 कुछ है moves में जो अभी starting is the middle value and ending is the ending itself. Now middle becomes start. So the same thing which we have played just before we have implemented this, moving num minus 1 the thing, the 1 minus 1 thing moves comma as a starting to middle instead of ending. Now middle becomes ending. Now because nothing is there in the above thing, we need to push back starting to ending. After pushing the starting to ending to the moves, now we need to move disk n minus 1 comma moves comma middle to ending. मिडिल में है, अभी मिडिल से एंडिंग तक जाना है, मिडिल टू एंडिंग कम SRC. The two we have done recursion. So this small function we need to implement after the moves, after giving the values to here, after the recursion we will be printing out the answer for auto x to move c out x of 0 and x of 1. That's it. Yeah. Creating strings. Here this is again very simple thing. Here what we need to do here, generate a string. Your task is to generate all different strings that can be created using its characters. So basically a string has some characters, right? Now we need to generate all possible permutations using it character. For this function we will be having an inbuilt function in the STL, next permutation. It's directly we can go to that score because there is nothing any algorithms we are using. It's direct an inbuilt function in the STL library itself. So here first we need to sort. First we should be at the first position of the string. First we need to sort everything in the from s dot begin to s dot end. Next we use a set string to collect permutations, to collect all the permutation. Why we using a set? Because we don't need a set makes sure that we will be not having any kind of duplicates in the set. So that's why we use a set. Now permutations dot insert do while. Do means first we will be doing the first thing and next we will be checking the thing. Do permutation dot insert of current string while next permutation s dot become s dot n. Here instead here next permutation does one thing. It checks if it is possible to do a permutation, and if it is true then it does the permutation. It goes, the string will be updated to the permutation and it returns it true. If it is not possible, if it is at the ending last permutation, it just simply returns false. So that's why I'm using do while, and we have not done implemented again next permutation over here, because next permutation basically does it moves. If the permutation is possible, then it updates things to the next permutation and it returns a true value. That's why here it simply returns true, and we simply insert the s at the do in the do loop after the while loop. This is actually this famous code. It's very famous. This do while for printing permutation itself. This do permutation dot insert as while next permutation of s dot become is the standard template for printing the all kind of permutation of a string. So cout permutation dot size and l for first we need to first we're printing the size of the permutations, all kind of permutations, and we're directly printing all permutations. Next print all unique permutations in the lexicographical order. So that is this question. Now apple division. Here there are n apples with known weights. We are having n apples. Your task is to divide apples into two groups such that the difference between the weights of the groups is minimal. The difference between weights of groups is minimal. Here what we will be doing is that, one second. Here also we'll be using basic small recursion again. Here using backtracking, what we can do for every element, whether we can keep it in set 1 or we can keep it in set 2, and once we have reached the ending position, we just need to make the difference. We just need to observe the difference between set 1 and set 2, and we just need to return that particular thing. And if we're at the ending and even the beginning in the middle, we just need to do we go to the next permutation. I will explain it here. Yeah, here what in the level, say solve x comma y x, like idx where we have idx and an array which we store and sum1 sum2 and n, the total number. If index is equals to n, if idx equals to n, we're at the ending of the array. If we're at the ending of the array, we need to return absolute of sum1 minus sum2. We just need to return sum1 minus sum2. And later after this we need to return minimum of choose comma not choose. So that's it. Sorry for the delay. Yeah, charging my pen is completed. Yeah. Now we need to return the minimum. We need to return this absolute difference. Now, if it is not equals to n, now what we will be doing is that we will be using solve idx plus 1. Solve idx plus 1. It's actually returning something. So this one like value 1. Value 1 is solve idx plus 1. Array will remain same. And here sum 1 plus array of idx comma sum 2. Yes, now value 2 equals solve idx plus 1 comma arr comma sum 1 comma sum 2 plus idx. Yeah, now we need to return the minimum of value 1 comma value 2. That's it. Minimum of value 1 comma value 2. So this is what we have to do in this. This is what we are going to do. The reason we can clearly observe from here, basically given an array, we'll be having an array. One sec. Yeah. What is the example? 32741. 32741. Sorry. Appellation. Yeah, 32741. So basically we can, what's wrong? We can go to first, we can take this 3 in someone, say 3 in someone. We can take 2 in someone, say someone comma sum 2. Initially 3 2. Now we can take 7 in someone, or we cannot take 7. If we take 7 in someone, 3 plus 7. And we can take 4 in sum 2 and 1 in sum 2 plus 4 plus 1. Now we will be checking, if we are at the ending, we will be checking difference of this thing and difference, and we will be returning the thing. And what we'll be doing is that in the middle, if we're at, say for example 2, then 2 can be gone to sum 1 or 2 can go to sum 2. Now we'll be using the 2 iterations. 2 can be going to sum 1 and getting the answer, and 2 can be going to sum 2 and getting the answer. Whatever is the minimum of this thing, then that we need to return. That is the solution. So if we see the solution for this code, we are in the, I think this is some 16th question. Yeah, so this is the solution. So what is in this solution, what is there? The whatever I have explained, the same is there. So solve int idx, the index where we are currently at, arr, the given array, basically the given array, sum 1, sum 2 and n. If we have reached the ending, index is equals to n, then we need to return absolute of sum 1 minus sum 2. In the next thing, choose solve idx plus 1 comma arr comma sum 1 comma sum 1 plus arr of idx comma sum 2 comma n. And not choose is solve idx plus 1. Not choose means we will be adding the correct value to the sum 2 instead of sum 1, means sum 2 means the set 2. Here luckily they haven't asked us what is the value of sum 1, what are the values in sum 1 or sum 2. If they have asked, simply we will be maintaining a vector for sum 1 and a vector for sum 2. As soon as we have written here sum 1 plus of arr of idxx, then we will be push back that arr of idxx, and after the choose statement we will be pop back that arr of pop back of sum 1 as a vector, and we will be pushing that particular ARR of IDX to the vector corresponding to the sum 2, and after the not choose also we will be pop back the, because it should not while we are backtracking, we should not unnecessarily include the value which is not corresponding, which is not present in the thing. So that two small addition we can do here, that is not asked, we just need to return its the main difference. So that's why we can simply use the sum 1 sum 2 variables, and for the not choose and not choose, we can select the minimum one, and after checking minimum one we can return the answer. So this is what the thing. So int I is equals to 0 to I is less than n, Cn of ARR of I after taking all the values, in answer is equals to solve of 0. We are starting at the 0th index, ARR 0 comma 0 n, and will we see out answer which is ender and return. This is again a simple question, apple division by using recursion. There are two recursion problems, chessboard and queens. This is, I think it's 17th question. It will take at max 20 more minutes, I will 15 minutes. I will try as fast as possible. Here chessboard and queens, this is also a very standard question asked in most of the interviews. All of these questions are asked in most of the OA rounds. I have personally observed so many questions. That set division question, that the following grid queries and the digit queries question, these are already asked in interviews. Your task is to place 8 queens on a chessboard so that no 2 queens are attacking each other. Simple, 8 queens are there in the chessboard. We need to place 8 queens in the chessboard such that no 2 queens are attacking each other. And as an additional challenge, there are few square in a chessboard such that it is not we do not actually place any chessboard, any queen over there. So almost most of the people place chess, and if the people who are not playing chess, we can easily observe that a queen can in the chess, it can go above, it can go up, it can go here, it can go here, it can goes in the diagonal ways, it can goes in this diagonal. So in all 8 directions it can go in the chessboard. Now in my code there are so many ways of generating the code for this thing. In what I have implemented is I have taken a square. It should be like 8 cross 8 basically. Now for every row, I have checking every possible block in the row, if it is possible or not. If it is not, if there is no, is there any queen in the same column? Is there any same queen in the same column, or is there any queen which is attacking me diagonally with the down diagonal, or is there any queen which is attacking me the up diagonally? So for checking the same column, if the column, if there is a queen in the call, some call of I is equals to 1, if this is the, like if the queen is placed in a particular column, we can make variable column of I as equals to 1. If the queen is there in the column 1, then we can return false. So there is the particular block is not valid block. If it is equals to 0, then we need to check diagonal. How we can check diagonal? Basically diagonals have a very good properties. So 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, in that way. Basically the say here that is moving from this one to here, right? 4 comma 4, 3 comma 3. So instead of this primary diagonal, if we check any of the normal block, say this is 1 comma 2, now this is 2 comma 1, in this way. So it goes on, and we can clearly observe that this is here x plus y is constant. So this is like x plus y is constant. Any place you go there, x plus y will be constant. And in the similar way, reverse this one. Here x minus y will be constant. Say 1 comma 1, 2 comma 2, 3 comma 3. X plus y will be constant, and x minus y will be constant in this direction. So that's what the difference is. This one and this one. So using these two, here a small change for this thing, as x minus y, here y can getting negative, this can be negative. So as a standard practice, what we'll be doing is that we will be checking diagonal of x minus y plus 8, this, if this is same, if this is the same value, and we will be checking for this value, and whether if queen is present in that particular cube, or also we will be making this as 1. If it is not present, we will be making this as 0. This is small change because we prefer not to keep any kind of negative values, because here we'll be using diagonal index, like basically ARR of 8, 1 2 0 1 2 3 4 5 6 7, right? So for 0 means x plus y is equals to 0. This is one diagonal, x plus y equals to 1. It's another diagonal, it's another diagonal, it's another diagonal. Like these are diagonal, this is representation of diagonals. And similarly, x minus y plus 8, this making sure that it doesn't make any negative indexing. For negative indexing, it will be an error. So to avoid the negative indexing, we are adding a plus 8 for this thing. So simply we will be checking whether if there is any queen present in the current column, or any queen is attacking from the diagonal above and diagonal this thing. If all the three are not there, then we can keep a queen over there, and we can go to the next possible element in the next row. That is just the code, that is just the logic over here. If you see the code, you will observe, you understand very deeply. Yeah, so in this code, what we have done, it seems like a little bit more, but it's very easy. It's just simple checking. So in main, we are having a board string of vector of string. We are having 8 inputting 8 strings consecutively, and for vector of bool, we will be checking column. For column checking, we have initializer 10. Why, you can ask why 10 20 because it's only 8 cross 8. It's like having a padding. In the machine learning also, we will be adding a 0 layer to the outer of the queue. In the similar way, we'll be having for making it's very good, we will be making the diagonal, the boolean array a little bit larger, and make outer ones all as true from the starting, such that it doesn't exceeds. In case it exceeds the limit, then also it should works with without any kind of error. So that's why we are actually using the extra limit. It doesn't harm unless and until it is less than the given the limit required one. Everything always having greater than enough is good. So when answer is equals to 0, solve board 0 comma check call comma diagonal 2 comma answer. Here board we're passing in 0 is the 0th row, and check column at 0th row, check all the columns, select 0 comma 0 0 comma 1 0 comma 2, and check diagonal 1 diagonal 2 and answer. if all are okay, like this is a solve. So boolean of board, int of row, vector bool of check call, vector bool of diagonal 1, vector bool of diagonal 2, vector int of answer. So if row is equals to 8 means from 0 we have reached 8 means after 0 1 2 7 is the last. We have already passed 7 means we have used 7 8 queens already in different positions in the different columns, and then we reach at ending. We just need to return answer and return 1 as an answer. So what we can do is, for int call is equals to 0, call is less than 8, call plus plus, if board of row call is equals to star, if board of row comma call is equals to star means it's not allowed over star, and check call, like we'll be checking column if any element is present in the current column or not, no, or if checking the diagonal diagonal of row minus call plus 8 and diagonal of row plus call, if all of these are, if any of the thing is positive, then we just need to skip that particular block. So we just need to simply continue. Next, if any of the thing is not there, then we will be marking all as true for that particular block, that we have reached that particular block, we have marked true, and now we will be going to the next row. Check call diagonal to answer, and check call of, now what we can go is, after making we have going to the next recursion, right? After we need to make this as false, as backtracking should be suffice. We should not make any kind of error over here, and so that no backtracking is possible for here. So that's why we'll be using this thing over here. Backtracking is used, that's why this diagonal everything is written kept as false, and initially everything is kept as true. So the simple thing is the simple recursion function was implemented over here, and sorry for scrolling. Simple implementation is done over there, and after the entire thing is done, we will be having the count of answer, and we will be returning we will be printing that answer. Simply we will be just implementing a check. We are not doing any DFS, anything. We don't need to do anything. We just need to have 8 queens. When having 8x8 chessboard, this is very difficult if it is asked like 2 queens problem, like for n×n chessboard. If count all the possible queens which are present in all possible 8 queen positions, then that will be a different case, and maybe that will require some more sophisticated problem solution than this. But in this is a simple one, 8x8 only. Its chessboard is fixed, the number of queens is fixed, queens are fixed. We just need to make sure there is no queens is attacked, and we just need to do a simple recursion, and we just need to continue. So this is the code for this question. Okay, so we'll be going to the next. This is 18th question of induction. 18th question is digit queries. So this is a very good problem. So what it requires a good mathematical modeling, but the solution is very small and simple. Coming to solution is a little bit difficult. Consider an infinite string that consists of all positive integers in increasing order, int 1 2 3 4 5 6 7 8 9 and 10 11 12. Like, it's basically an infinite string, it goes on and on and on. So we can directly expect from this particular string statement that what might be the problem he is asking. He's just giving an index or the nth position of a string, and he's asking the digit. So that's what he's asking. So your task is to process q queries in the form what is the digit at kth position k in the string. The first input string has an integer q in the number of queries. After this, there are q queries that line describes. So here we again use mathematical modeling and some recursive patterns. Say 1 2 3 4 5, 6, 7, 8, 9. How many are there? It is 9. If these are one digit number, if we check a two digit number, 10, 11, so on, 99, how many are there? If we count, because we are very fortunate such that it is exactly 90. If we check for the three digit number, it is exactly 900. If we check four digit number, it is exactly 99000. So for n is equals to 1, it is basically 9 into 10 to the power of n minus 1. So these many numbers are there from for one particular, for nth, these many numbers are there for nth length, like n is equals to nth digit numbers, n digit numbers. These many n digit numbers are there. These many n digit numbers are there, and so now we need to count all the numbers. So how do we do it? So it is n into 9 into 10 to the power of n minus 1. So these many digits will be there after n digit numbers. So for example, in the simple terms, all the numbers for all the digits are for the which are covering all the one digit and two digit, means 1 into 9 into 10 to the power of 1 minus 1 plus 2 into, here we need to count all the digits, 2 into 9 into 10 to the power of 2 minus 1, it's basically 10 to the power of 1. 90 into 2, 180, and 9, 189, so 189. So the 100 will be starting from 190th position. So 190, if k is equals to 190, so what is the answer? Is 1, because it is just starting 100. If it is 191, k is 191, it is 0. 192 means it is again 0. 193 means it is again 1, because now it is 101, it is again 1. So in this way we can actually count numbers. Now okay, that is the counting. So for k, first of all we need to know where does k lies, what actually the area in which k, like k is in the area of a two digit number, k is in the area of a one digit number, k in the area of some three digit number or four digit number. How do we find it? We find it by subtracting the number of digits from the corresponding one digit. So while k is greater than 9 into 10 to the power of say n minus 1 into n, and here n will be incrementing, in here n will be incrementing, n plus plus, and k will be decreasing these many values here. Okay, so what we'll be getting is, we will be having like and we'll be having, say for example, k is equals to 1, say 200. So we can subtract 200 minus 9. We can subtract 200 minus 90, because it is 90, right? 900. Now what we can do is, from here, after subtracting 1 from 9, what will be reaching is 191, right? After 90 it is 101, right? Now so for this 101, what we can do is, now this 101 is less than 900, which is the total digits of 300, right? So 101 is less than 900, so 101 falls in 3-digit area. So this falls 3-digit area. So what we need to do to get the exact location, exact number where it is there, is by dividing 101 by 3. Because for say it's everything is mathematical over here. So 100, for 100 we just calculate is 190, right? So for 191 also it's from 100, 192 also is for 100, and for 101 it is from 193. So for 190, and for from 190 we have removed all the previous values, then we will be having 0, and for this thing 0, for this thing 1, for this thing 2, and for 101 is 3. Like simply 1 2 3 4 5 6 7 8 9 10 11 12, right? So here these are the 9 values, right? So if k is some 10, k is some 10, now from 10 we are removing, this is the, say k is equals to 10, this is 1 2 3 4 5 6 7 8 9, and this is the 10th, this is 10 11, and we k is equals to 10 over here. Now k is k minus 9, we will be having k is equals to 1. Excuse me. So k is equals to 1 over here. Now so k is equals to 1. If we divide it by 2, what we'll be getting is, it's 0. So 0th means 1. 0th means the first one. And if k equals say 3 divided by 2, then it is 1. So that is means it is of 11th one, means the second integer. If k if that's why some the after subtracting the k divided, after subtracting the k divided by n will be giving the xth number from this number from the starting of n digit. Now okay, we have so we got either 10 like 110 or 11 or 12, we got the number. Now in this number, how do we get the digit? Now we just need to take the fraction, like k fraction of n we will be giving the digit. Here we will be having k as 1, right? 1 fraction of 2 is equals to 1. Here this is following one indexing, like 1 2 3, that indexing. We can have k minus 1 fraction of n to have 0. If it is 0, then that is the first element in the particular number. Now for k is equals to 10, so total for k is equals to 10, first we need to remove 9 from 10. What will be getting? 1. So for 1 we need to divide by 2, we will be getting 0. So 0th means the first one. So for here also, instead of making this one indexing, we can keep as 1 minus 1 by 2, that is equals to 0. 0 means first. This corresponds to 1 0. This is the number. Now we can be, we just got the number. So out of this number, which digit is it? It's like k. This k means not the 10. This one, this updated one. Here k minus 1 fraction of n. If it is equals, you know, it is equals 0. 0 means this is 0, this is 1. So this is 1. That is the answer. So this is, so for example, we can keep in the example it gives like 19, right? Let's keep 19. 19 minus 9 is 10. 10 divided say 10 minus 1 is equals to 9. 9 divided by 2, what is equals to, it's 9 divided by 2 is 4, right? 9 divided by 2 is 4, and 9 percentage, 4 means fourth, means 10, 11, here 10 minus 1 divided by 10 minus 1 divided by 2, right? Here 19 minus 1, here 10 minus 1 means 9 divided by 2 means 4, means it is 0 indexing. So 0 corresponds to 10, 1 corresponds to 11, 12 corresponds to 2, and 13 corresponds to 3, 14 corresponds to 4. So now the number is 14. How do we get the digit? Same, 9, like 10 minus 1 percentage of 2 equals 9 percentage of 2 equals 1. Here 0th index 0, this is 1, means 4 is the answer. Check answer. 19th one, 4, that's second query. So 4 is the answer. So this is the way in order to find the number. So in the code we can get more clarity than this. Simply so here we are just using the power 10, because we every time we need to multiply by the 10 times 10 to the power of n minus 1 into 9 into, and so we just use the power terms to make the equation a little bit beautiful, pretty. So signed main int q, c in q, int k, q queries for int k. We will be taking int k can be initialized inside the for loop or outside the for loop. We just be maintaining the taking the values. So int I is equals to 0, I is less than q, I plus plus k. K is the index. Now starting with n is equals to 1, we are just removing all the elements which are less than k, like kth digits. Now k is equals to say 19. Now for 19, now k belongs to 2 digit, right? So from the 2 digit we are just removing all the 1 digit numbers from k. So while k is greater than n into 9 into power of 10 to the power of n minus 1, while k is greater than this thing, then we just need to remove all the lower digit numbers from the k. From k, after removing lower digit numbers, all the lower digit strings, now we incrementing n plus plus. Now we will be having with n plus 1. Now here k, once k is less than, means the k belongs to that particular class of set, where now n is the number of the length of the each number in which class k belongs to. For the case of k is equals to 19, k minus 9 is equals to 10. So the 10 here once will be n is equals to 1 for the first case, right? So once we are in the loop, now n will be becoming 2. Now it is k is 10. Its k is just 10. 10 is not greater than 90. So k belongs to nth class, means 2, means 2 digit number is the k. So that's why. Now how do we get the number? Int number is equals to k minus 1 divided by n plus this number. It's 0, like if it is k is equals to, if k is equals to 10, we got 10, right? So how will we get 10? It will be having, we should add that to the power of 10 of n minus 1. 10 plus 10 to the power of n minus 1 plus that particular, means the last digit, the highest value of the last n minus 1th digit numbers plus the current positioning indexing, that we should do. That's what we're doing here. K minus 1 by n is the nth number, say nth number plus power of n minus 1, means how many numbers are there in the previous thing, that number plus this thing is the current number. What is the location? K minus 1 percentage of n. So toString cout toString num, we have finished making this num, we have made this a little bit prettier. toString num of loc handle, means this number, say 101 is the number, 6k some random number, 101 we got from here num. So location is 2. So instead of simply we're converting the number to a string, and now we can access the string with the indexings. That's why we can use it this location to access that. That's why we have convert the number integer to string by using toString function, toString num of location. So this is what we are doing in this problem. Simple. This is as compared to the previous one, this is again simple. This power of 10. So simple, just we're subtracting whatever the last digit numbers, and we're finding which class of digits but as the current belongs to, and we're finding current number by dividing by n and adding the max value of last number, and finding the index. Now we got the index of the current number. Now we have converted the number into the string, and we have accessed the current digit of the number using the indexing it by string. So see out toString num of location n. So this is what the code is, and this was solution for this problem. So if we check to the last problem, grid paths, this is 19th question of introductory problems. The same digit query is explained in almost 20 to 30 minutes. Few channels have also explained it around 50 minutes. This question is explained for 50 minutes by some channels. I am going to explain 5 to 6 minutes itself. Now here what will be given is there is a grid. In this question there is a grid. Now what we need to do is from the upper left square to lower left square, from here to here we should go. From here to here we should go basically. So now there are actually these many paths, 8, 8, 4, 1, 8 paths in this grid. Now for all these paths we will be having okay, that is the information till now. So what will be given is this is the definition of path, dr. There are only 4 directions. In some cases can be 6, it can be all the 8 directions. In this case only 4 directions, down, right, up, right, down, down. There are only 4 directions, down, up, left, right. So in all the 4 directions it should go from here to here. Now what he is asking is, he can have a query like this. The question mark can be any kind of direction. For this question mark we will be having some positions R, U, L, D, D. So we should find how many paths are actually there, such that the locations, question mark can be any direction, but the specified direction should be the same. So out of these 8, 8, 4, 1, 8 paths, how many paths are actually having any kind of direction in the question marking space, and the exact same direction which is marked in the given space. So this is what the count, we should return the count such that this is possible. So how do we actually do this problem? We don't need to do any kind of DFS. We just need to do a simple check. We just need to implement check, because we're doing in the DFS problem. Here what are the possible checks? I will open the one note. So this is a small thing. So if an element is over here, we reached this thing, right? We reached the the bottom left right element, this ending point, and the current string, as we are moving to the path, we will be making a current string, and we will be checking with the given string, right? If the index of the current string is equals to 48, it is 47 for 0 indexing, is 48th one, 48. If it is 48th move, and it's expressed 48 characters, we can go in each path corresponds to 48 characters. He has fixed the length of the path, for the fixed path length. Or else if path length is also not fixed, it is then that goes to some billion numbers, the total count. Now only it is around 88,000, so with the fixed path length, that too. So 48 is the thing. So with by using 48 steps we have reached this thing, then that is a valid solution. We need to add +1 to the count, total count. If it is not 48, and we reach at the ending, then we need to return -1, or we need, it's not possible, we need to return nothing, 0. We return 0 and we need to return nothing. So that is one constraint. And the next constraint is, for suppose we have a Rachel, like it's like the dots are representing not for, if it's true, we have reached this true, but now here it's false, we're at this location. So this is like a trap, which can be possible in this question. So after failing for some submissions, I have get to know these things. So this is true, this is false, and now we're at this location. So you can think that we can go up and down, right? But that is not the case, because if we check from here true, if we go to this direction after marking this as true, then actually this is like a junction, right? This forms a junction, but it is not possible here in this question. It's not possible to make such kind of junctions. So this is like a dead end. So whenever we reach such kind of dead ends, just in case, then we just need to return false. It is not possible. We can reach them like true, we can go down true, we can go down true, we can go down true. Now we're at here, this is false. So if we reach this one, then we can't go over anywhere. So this is false. So we reach, now we are at here, this is false and this is false. So if we reach here and we should go here, now it's like a junction, but it's this kind of junctions is not allowed. This kind of things is not allowed in this question. It's a single straight line and without any junctions. Like this, you can go like this, but it's not like this. It's not multiple path. There should not branches. So this is, we should check these cases. So this is one case, and this is also another case. True, false, and we're at here. This is also another case. So these two cases and the starting base case, and he already explicitly given that when it is a star instead of a dot, then we have this, that is not allowed. That is also not allowed. That is also we should keep in mind. So these are the conditions. Now if these conditions are satisfied for a particular grid, okay, so it's not dead end, it's not the star, and it is a dot, and it's so now it can has two possibilities. Now it is a valid box. Now it has two possibilities. What is for the, it can be question mark, or it can be a target. It can be directions. Say in this L R L U down, right, left, up, down. So it can be a question mark, or it can be a right or left or up or down. So if any of these thing, what we should do is, if it is a question mark, then from this box we can go to all four directions. We can check all four directions. But if it is this one, we just need to go to this direction. That is the simple case. Now how do we exactly goes to that directions? By simply giving indexing. So what I have implemented is some dr kind of thing and dc kind of thing. So it's -1, 0, 1, 0, and it's like 0, 1, 0, -1. It's like left, and it's like up, it's like down, it's like so it's basically up, and it is it's basically up, and it's like it's down, it's basically it's right, and it's left. So such that up is having a 0 index, this has 1, this has 2, this has 3. So whenever it is up, you have encroached this thing. Now dr of u, we can go minus a, like we can make some indexing corresponds to like 0 1 2 3 correspond to a particular direction. So if it is that particular direction, we are only allowed to go to that direction only, and we simply moving till ending. If it is a question mark, we can go to all four directions. You can clearly observe the difference in the code, which I am going to discuss now. So let us go to code. So this is the code. One sec. Yeah, this is a little bit bigger code, but it's very easy. Basically, it's nothing inside the code. So these are the directions. Initially the length is 4, means the length means the direction length is 4. It's either upper, right, down, and initializing dr of length is equals to this thing, dr of length is this thing, and plen means the total phrase path length is equals to 48, and int p means path and plen is path length. We're initializing a and big array of path length and constant of g size. Grid size is 9. Here actually grid size is 7 comma 7. It is given at 7 comma 7, but we're starting with one indexing, and this 7 comma 7 is because we are using 9, because for 1 to 7 we can keep normal things, and we can keep an extra layer outside the 7 comma 7 grid, such that it will be safer. In the below of the code, we can observe why f keeps grid size equals to 7. So bool on path grid size comma grid size, like 4 comma 4 9 comma 9 on path, like whether it is in path or not. So for the main, initially, so in the main we will be taking string line, like whatever the line is there, the big line, whatever the strings are there, right? It is given as, once okay, yeah, it's given as a very big string. So string of line, get line, scene of line. Okay, now for int I is equal to 0, I is less than p len I plus plus. Now char is equals to cur is equal, like we are extracting the particular character of that index, and for every, like if it is equals to u, then like basically what we're doing is we're taking a string and we're already initialize an array. Now for simplicity, we're converting the string into 0 1 2 3 4, means 4 means a question mark, we can go to any 4 directions. 0 means one direction, 1 means second direction, right, 2 means down, 3 means left. So in this way, if cur is equals to u, we're taking the character and we're converting character to the number, and we're storing that number in that particular location of a string character in our array, instead of using the string again, and that actually simplifies so much. So for int I is equals to 0, I is less than grid size. Here this is like padding. So wherever if we goes and out overflow, if the indexes, whenever for just case, if it overflows, then we can have a padding true, all are true. We were having 1 comma 7, like 7 comma 7 matrix, right? So 1 to 7. So for 1 to 7, what we can have is 0 to 8, 8 to 0. The outer level, a square of 1 comma 7 is embedded in the 8 cross 8 square. That's what we're using here by using 9 as a grid size. So whenever we reach at the ending of, whenever we overshooted the 7 comma 7, it is already true, it is already reached, we're already marking here true over here. So they seizes an opportunity, that blocks an opportunity for overfitting, because in the above, I can show you here itself. So here, if on path is not, if it is false, then only return is equals to try path idx plus 1 comma r comma c. If it is false, then only we are moving. Here already we have marked it truth, so that there wouldn't be any kind of possibility for overflowing. So that's why we are using 9 comma 9 as grid size. Now this is the for I is equals to 1, I is for all of the 1 to 7 comma 7 we are marking it as false. For all padding, for all outer layer we are padding, making it as true. Now we will be starting with 0. Starting row is 1 and starting column is 1. Now answer is equals to try path str comma start str starting row and starting column, see out answer and elder. So what we're doing in this version, we're just finding the first 3 conditions are there, right? On path of current comma current C minus these are just whatever discussed. This is like first condition is I can decrease the size so that you can able to see this thing. Yeah, like these are left and right. This is top and bottom. Top and bottom are false, left and right are true. Then return 0 because it's false, and top and bottom are true, left and right are false, return 0. And if what we can do is current row is equal to 7 and current column is equal to, means we have reached the destination, and idx is equals to plen, then return 1. Yes, we have arrived with the correct location with correct number of moves. But if it is not the case, then we need to return 0. That is over here. So now if all of these conditions are passed and it is in the middle value, now int ret is equals to 0. Ret means what we need to return the value, the total repetitions answer type is equals to 0. Now we are marking on path as true. For this, now we have reached this thing particular block, we should mark true for this block. And after marking true, so if p index, we have initially converted the character into index, right? That's what we are using here. If it is less than 4, means it is any of the 4, it is specified in the string, then we are going to that particular direction using this dr and dc columns. This is the standard way, as I already discussed. -1 comma 0 means now we are at 1, say for 3 comma 3, for 3 comma 3 are there. Now for u it is -1, it is 0, like here dr of 0, p of 0, some x is 0. Now that corresponds to this thing 0. So 3 comma 3 plus dr plus dc means 3 minus 1 is 2 and 3 plus 0 is 0. So now it becomes 2 comma 3, right? Now what happened here? 2 comma 3, 3 comma 3 is a 2 comma 3 means it moved upward. In the similar way, we will be moving to the given direction it is there. If p of index is less than 4, then rc will be updated according to dr and dc with according to p of idx and p of idx. If on path of r comma c, if it is not equal, it is not visited yet, on path of r comma c is not visited yet, then this r comma c is the next move, right? The current move already visited true. The next move, if it is not visited, then we will be adding the value, the try path of idx plus 1 comma r comma c. We will be idx plus 1. Why? Because it is next move. That's why idx plus 1 comma r comma c, we will be trying that path. If it is true, it is returning 1, and if it is returning 1, then that is the good thing. Else for I is equals to 0, I is less than it is not the case. We can if it is question mark, then it is p of idx is equals to 4. From here p of idx is equals to 4 if it is a question mark. Now this will be using else for I is equals to 0, I is less than n, I plus plus, r is equals to current plus all the 4 directions we are going. If it is not visited on path r comma c is continue. If it is already 2, it is continue. We don't need to do anything. Return of r try path idx plus 1 comma r comma c. Go to the next thing in all directions. And at the ending, this is most important, on path of r and cur c should be initialized to false, because in backtracking, after moving to the next possibility, we are coming back again, right? After coming back, we should make the position state to the original state. We have updated false to true. We have gone to back, tracking, and after coming back we should mark that true to false, otherwise it will be returning a false answer every time. Now after all these things, we should return the answer value as an answer. So this is how we are checking all the four any dead traps, and checking whether any is already visited, or checking if we visited early or not. All these things we after checking will be returning true 1 or 0, or and after going to all the parts we will be printing the answer for this question. So that is simply this code for this thing. For summary, this we're just checking whether the current index, current row, current column is it's possible or not, if it is a valid block to move in or not, and it is also not visited, then we will checking towards okay, it's valid move. Now we should go to the next thing. If it is already given in the direction, then we are only confined to go to that direction only. If it is given a question mark, then we are going to all the four directions and checking if it is possible to get an answer or not. So that is how we are using this the code for this question. It is also accepted. So this is the 19th question, the final answer, final code solution for this thing. Great path. So I hope you all like this video. Please like, share and subscribe this channel, the coding project.